All right, welcome back, everybody. So this is a video going over section 5.8, day 1. So just as always, we're going to go through a warm-up. So why don't you get out some paper to do a warm-up on. Make sure that if you have not already done so, please submit the worksheet. Okay, we'll go over that in a second, but make sure you submit that before I go over it. Okay, here we go. So again, why don't you go ahead and pause right now and try these three. You can do this in whatever means necessary if you want to do the solve for b method or if you want to do the slope intercept or the point slope method. Either one is fine with me. I'll probably show the solve for b method twice and then the slope and the point slope method once. Okay, so go ahead and pause and then play whenever you're ready. All right, so for the first one here, I'll go, this one I'll solve for b, 5 I'll do point slope, and then 6 I'll solve for b as well. All right, so solve for b here. That means I know that, if I've got y equals mx plus b, and the m is 1/5, and I've got 0.2 comma -6, that means this is going to be -6 is equal to 1/5 times 2 plus b. Okay, now at this point, because that's a fraction times a whole number and it's not going to come out nice, at this point you can do a decimal. It's okay to have a decimal for your y-intercept. It's not okay to have a decimal for your slope, but it's okay to have a decimal for your y-intercept. So 1/5 of 2 is 2/5, so it's 0.4, 0.4. Okay, and then when I subtract it over to the other side, that's going to give me -6.4 is my b value. That means my answer is y is equal to, again, use my slope, my 1/5 times x minus 6.4. Okay, there's number 4. All right, next one up here, I'm going to use the point slope method. Remember, point slope is y minus y1 is equal to m times x minus x1. You're going to need to know that formula and be able to just plug in the values for your quiz, which is coming up on Friday. But in terms of solving this one for y, you're not going to have to know that if you like to do the solve for b method, but this is just an alternative to the solve for b method. Y minus 5, again, I get that from my y value here. Y minus y is equal to slope m, x minus x. And at this point, I just go ahead and I solve for y. Get that one here. Y minus 5 is equal to -4x plus 4. And then I add the 5 over to the other side. So y is equal to -4x plus 9. That's my answer there. Okay, and my last one here, I'm going to do the solve for b method again. This is a weird one because the slope is 0. It's going to come out to be an odd one, and I'll show you what I mean here in a second. It's going to come out to be a special case. So again, y is equal to mx plus b, where my m is 0, my y is -7, my x is 3 plus b. And now what happens here is -7 is equal to 0 plus b. Okay, -7 is equal to my b value. However, the weird part about this is that my slope is 0. What type of line, let me ask you this question, what type of line has a slope of 0? Hopefully some of you are saying this type of line has a slope of 0. And the equation of that type of line is just a y equals. Now how do we get there then? Well, it's y is equal to m, 0, x plus b, so -7. Now what is 0 times x? It's 0. 0 minus 7 is -7, and that's my answer here. Y is equal to -7. Please don't say y is equal to 0x minus 7. You want that to go away because if it's a horizontal line, it should just be y equals the constant. Okay, hopefully we did all right on those three. Why don't you get out your worksheets and we'll go through them. All right, so I'm on the 5-6 side, so make sure you have that side out front. I'm just going to go through the answers here. If you have any questions, if you really are struggling, you can email me. We can set up a time to conference. And yeah. Okay, we got y is equal to 4x minus 3 for the number 1. Y is equal to -2x plus 0, so we'll just say -2x. Number 3, y is equal to -1/3 x plus 6. Okay, now this one over here, Again, sometimes when they put these blanks in here, they're trying to walk you through it, but it doesn't actually help you in the end. It kind of almost like makes you a little bit more confused. But they're trying to walk you through solving for b. So we say y equals mx plus b, and then we take 2/5 of 10 to get 20 over 5, so 4. And then we subtract over to get a -1. So y is equal to 2/5 x minus 1. 2/5 x minus 1. Okay. Graphing the line here, we have, now remember that we should write it in slope-intercept form, which means I got to get y alone. So I subtract x to both sides. So y is equal to -x plus 3. That means my y-intercept is 3. And I have a slope of -1, down 1, right 1, down 1, right 1. All right, now I'm going to use the line tool because obviously I didn't get making lines on this tablet. There we go. Okay, the next one here, it's almost solved for y, but all I have to do is just subtract 4 over to the other side. That gets me y is equal to 4/3 x minus 4. So my y-intercept is -4. And my slope is 4/3, positive 4/3, up 1, 2, 3, 4, right 3. Up 1, 2, 3, 4, right 3. Okay, now I use my line tool. There's my line. All right, last one up here. This is in standard form. We're going to put it in a slope-intercept form. First things first, subtract the 5x over to the other side. That gets me -2y is equal to -5x plus 10. And then when I divide over the -2, that gives me y is equal to -5 divided by -2 is a positive 5/2. Don't say 2.5. And then 10 divided by -2 is a -5. All right, so that means my y-intercept is -5 with a slope of positive 5/2. 1, 2, 3, 4, 5, right 2. I think I put it at 6. I'm sorry. Yeah. And then up 1, 2, 3, 4, 5/2. All right. And there's my line. Sorry about that dot right there. I'll erase that away for us. All right. So hopefully those ones were pretty okay. Let's move on to number 8. Number 8, the word problem here. Daniel works as a volunteer in a homeless shelter. So far, he's worked 22 hours, and he plans to continue working 3 hours per week. His hours worked as a function of time is shown in the graph. Write an equation that can be represented that represents the hours Daniel will work as a function of time. Now it says function. I'm okay if we use y equals though. Y is equal to 3x plus 22. That's my equation. Y is equal to 3x plus 22. The slope is 3, and that represents the amount of hours per week. You know, remember, always slope is always the rate, right? So you have to tell me something about a rate here. And then the 22, the b value is the 22, and that is the starting hours, amount of hours he's starting with. Find the total number of hours he works after 16 weeks. Now, there's 2 ways to do this. You know, I could come up here and say, okay, we're at 16 right here. So it looks like it's coming across at 70. But if I have my equation, can't I just plug it in? So let's do that. Y is equal to 3 times 16 plus 22. Let's see how close we got. 3 times 6, oops. 3 times 16 plus 22. So yeah, I was right with the 70. So we're going to say, find the number of hours worked after 16 weeks. We're going to say 70 hours. Okay. All right. Go ahead and flip it over, please. Write an equation in point-slope form. So again, point-slope form. Remember point-slope form, that's the y minus y1 is equal to m times x minus x1, right? So just, a lot of people always try to do too much here. You don't want to solve for y. That's if I asked you to put it in slope-intercept form. So all we're simply going to do is say y minus 2 is equal to 3x. Now, instead of minus a -4, let's say just plus 4. And that's it. Don't do anything else. Doing anything else would take it out of point-slope form. this one here, y, and then I would write minus a negative 1. So plus 1 is equal to m x minus 6. That's it. Okay. If I did ask you to put it into slope-intercept form, I would ask you to solve for y. Okay, but we don't have to do that. Now, the cool part about this one is if I want to go ahead and graph this line, look here, that's the coordinate in here, right? That's the coordinate. I could solve this for y if I really wanted to, and I'll show you that in a second. But this is the coordinate here, 6, negative 2, 6, negative 2. And then I use this slope, my negative 2/3 slope, down to right 3 or up to left 3. 1, 2, 3. Up 2, left 3. Okay? Now, let me show you something here, though. If I did distribute this in, I would get a y plus 2 is equal to negative 2/3 x, and then a plus, okay, 2/3 of 6, so that'd be 12/3 or 4. And then if I subtract over to the other side, that 2, I get negative 2/3 x plus 2, which makes sense. Y-intercept is 2, down 2, right 3, down 2, right 3, down 2, right 3. I'm getting the exact same coordinates that I'd gotten before. So there's my line. Let me just do that straight away for the next problem here. We distribute in here. So we're going to get y plus 3 is equal to negative 2x plus 8. And then we subtract the 3 over to the other side, negative 2x plus 5. So y-intercept is positive 5, and the slope is negative 2. Okay, make my line here. There we go. Okay, hopefully we're doing all right. And now for the last several here, I want to put these into slope-intercept form. I'm going to do the solve for b method for these. If you'd like to see the point-slope method, all you do is just put it in a point slope and solve for y. All right, so let's get going. We have y equals negative 3 is my y value. Negative 4 is my m. 1 is my x. Plus b. So negative 3 is equal to negative 4 plus b. Add the 4 over to the other side. 1 is my b value. So y is equal to negative 4x plus 1. Do the same thing over here. Y, which is negative 5, is equal to mx plus b. Oops, that's a plus sign over here. And then we have negative 5 is equal to negative 4. 1/2 times negative 8 is negative 4. Plus b, I add the 4 over to the other side. Negative 1 is my b value now. So y is equal to mx plus b. All right, now I have to now find the slope here. I have to find the slope. So we say negative 7 minus 1 over 0 minus 2. So negative 7 minus 1 is a negative 8. 0 minus 2 is a negative 2, so that gives me a positive 4. Now, this is unique for this one. That's the y-intercept. So I can just say minus 7. That one I'm not going to be able to do so much. Number 8. So let's show you here. I still got to find the slope. Give myself a little bit more room. Negative 2 minus a negative 6 divided by 2 minus negative 6. You follow me there? Negative 2 minus negative 6. 2 minus negative 6. So negative 2 plus 6 is positive 4. 2 plus 6 is a positive 8. So therefore, my slope is 1/2. Now, let's use this 2 comma negative 2. So y equals mx plus b. And we say negative 2 is equal to 1 plus b. Subtract the 1, I get negative 3 as my b value. So my final answer is y is equal to 1/2 x minus 3. All right, it says find the intercepts of the line that contains each pair of points. Now that's going to take a little bit more work, so I'm going to come down here and do number 9 and 10 down here. This one's a little weird. Basically what we have to do is find, we just have to find the intercepts of the line that contain each pair of points. I'm not going to worry too much about these. You don't have any quiz or test questions over them, so don't worry too much about them. But let me go through them nonetheless. Number 9 here. Got to find the slope first. So we have, I think that what the best way to do these ones would be, would probably be to just graph them. Let me show you. Okay. Let me show you. Here's number 9. And while we're at it, oh, you know what? I'll just use the same graph. Okay. I'll delete it away in a second so we can see 11. But here's number 9. First thing that we want to do is plot these points, -1, -4, and then 6, 10. So it says to find both the x and y intercepts. So let's hope that when I connect these dots, they're going to land at nice spots. Yep, and they do. All right, so the x-intercept is +1. So 1, 0. And then the y-intercept is -2. 0, -2. Okay. Let's do the same thing for the other line. Get this out of the way. Erase these points. And do the same thing for this one. Okay, so I'm going to graph those points. I'm at 3, 4, and -6, -16. Come on now. Okay, I'm going to have to do this one a little bit different. Ooh. Ooh. All right. I am going to have to find the slope. So the slope is 16 minus 4 over -6 minus 3. So 12 over -9 gives me negative, divide by 3, -4/3. Okay. So now when I go to make my line, I'm going to use 3, 4, make my equation 3, 4. I got y is equal to m x plus b, and that means we got y is equal to, okay, we have -12/3, so -4 plus b. Add the 4, I get 8 as my b value, which means that 8 is my y-intercept, right? So I know I'm at 0, 8. Now I just have to find my x-intercept. Okay, but my equation is y is equal to -4/3 x plus 8. Now, if you remember correctly, what I would do to find my x-intercept is put 0 in for y. So that's all I'm going to do. I subtract 8 over to the other side. I get -8 is equal to -4/3 x. And then when I divide that over, 8 divided by 1.3, 6. 6 is equal to x. So that means my other intercept is 6, 0. All right. Again, I wouldn't worry too much about 9 and 10. All right, number 11 here. The cost of internet access at a cafe is a function of time. The cost is shown. So basically what I want to do here is that since I know that it's linear, I'm going to find the slope and then use the points to find the y-intercept. Okay, so the slope, let's use these first two coordinates here. So the slope is going to be 7.25 minus 4.36 divided by 25 minus 8. Calculator here. Move that over so I can see it. 7.25 minus 4.36. And I know that's divided by 25 minus 8 is 17. So 0.17. 0.17. And I'm okay with using a decimal here because it's a word problem. Now, if my m is 0.17, let's use this first coordinate here and say y equals mx plus b. So that means I know that it's 4.36 is equal to m, 0.17, x plus b. So 4.36 is equal to 0.17 times 8. calculators up there. 0.17 times 8. And then I'm going to subtract that away. So I've got 1.36 here plus b. Subtract over the 1.36, and that is going to give me a 3 is my b value. So my equation is y is equal to 0.17x plus 3. It then says for 1 hour, so 60 minutes. Got to plug that in. So I would say 0.17 times, plus times 60 plus 3, 13.2. $13.20. Okay. All right. So next thing we should be doing is getting out our notes. Again, if the sub is not given them to you, make sure you get the guided notes. This is going to be section 5.8 day 1. We're going to do section 5.8 day 2 tomorrow. Section 5.8 is the last section out of chapter 5. We're going to be doing the second half of the chapter 5 quiz on Friday. It's going to be just over sections 5.6 to 5.8 though. Okay. All right. So parallel lines, we kind of already talked about them when we went over one of the homeworks. We talked about lines that have the same slope end up being parallel. We talked about them and that, whether it was possible or impossible. We're going over that homework. Parallel lines are lines in the same plane that have no points in common. In other words, they do not intersect, right? And that's really our definition. If I asked you guys, what do you know about parallel lines? You're going to say, well, they don't cross, they don't intersect. Really, the mathematical definition is that they have no points in common, okay? Now, what's unique about this is that two different non-vertical lines are parallel if and only if they have the same slope, okay? That's one of the key pieces that you need to know about this one. Also, all special cases, like if it's two vertical lines, they're going to be parallel, and also two horizontal lines are going to be parallel as well. But take a look at these points, these lines here. Notice how the slope there is 1/2. Slope down here is 1/2. Notice they're going up at that constant rate, and then that's never going to change. Right? So therefore, they're never going to cross, because they don't. If they change slope, they would cross. But since we know that they do not change, they're never going to cross. Now, okay, for these problems in here, I'm asking you which lines are parallel. I'm basically giving you 4 lines. I know it looks weird, so I'm just going to kind of partition them off right here. This is equation 1. This is equation 2. This is equation 3. This is equation 4. Now, when I ask you to define which ones are parallel, I'm asking you which lines have the same slope. So I guess the first question I would ask is, are they in a form that's easily identified, that we can easily identify the slope? Well, this one's in slope-intercept form, so pretty easily m is 5/3. Okay. This one, y is alone, so okay, good. Slope is 1. This one, good. Slope is 5/3. This one, okay, good. Slope is 1. How do I know the slope is 1? Because again, it's 1x plus 1, right? All right, now the things that I have to check. Okay, look. This slope is the same as this slope, so I'm going to conclude that 1 and 3 are parallel with one another. I just have to check and make sure that their y-intercepts are different, because if they're the same, then they're the same line, and that's not technically parallel. Okay, so we're going to say that line 1 is indeed parallel to, and that's the symbol for is parallel to, right? This symbol here means is parallel to. Okay, so we're going to say line 1 is parallel to line 3. Okay, and we can also conclude that line 2 is parallel to line 4, because look, the y-intercept is 0 and the y-intercept is 1. Okay, pause and try this one on your own. Again, I'm going to partition them off like this. Those semicolons there are just kind of making sure that you see the difference. It's kind of cluttering it all together. All right, so for this one here, again, we're going to name this one equation 1, equation 2, equation 3, equation 4. So for equation 1 here, the slope is 3/4. This one, I can't easily identify the slope. It's in standard form. So instead, let's solve it for y. I'm going to add the 3x over to the other side. That's going to give me 4y is equal to 3x plus 32. I divide by 4, 3/4 x plus 8. Okay, so my slope is 3/4. Here, my slope is 3. Okay, and here, let's solve this one for y as well. Y minus 1 is equal to 3x plus 6. And I add the 1 over to the other side. Y is 3x plus 7. Okay, my slope is 3. All right, so we may try to conclude that line 1 is indeed parallel to line 2. However, what did I forget to check? So can we say that line 1 is indeed parallel to line 2? No, we cannot. I'm trying to click on the eraser. We cannot say that. And we cannot say that because both the slopes and the y-intercepts are the same. So therefore, they're not parallel. They're actually lying right on top of one another, which is no good. But we can conclude that line 3 is indeed parallel to line 4. Okay, and we see that because the y-intercepts are different as well. All right. So there are going to be some times when I ask you to show that this is a parallelogram. Let me first ask you, what is a parallelogram? Well, isn't a parallelogram by definition parallel to each other? Now, what are parallel? Well, it's two sets of parallel sides. You can't just say one set. Think about it. What would be a shape with one set of parallel lines? Isn't this a shape with one set of parallel sides? And we're not talking about a trapezoid here. We're talking about a parallelogram. So I need to show two sets of opposite sides of parallel. So let's name them. Now, when I say show that, notice that there's not going to be like an answer blank here. Like the work is the answer. So here's like the minimum amount of work that I need to see. I need to show the slope for JK. And if you want to, you can say these are going to be the slopes. I need to find the slope for JK, the slope for ML, and that should be the same. And then I want to find the slope for JM, and then the slope for KL. Okay, now when I do that, I can just use the rise and the run to do that. Let's find JK first. Now, obviously, this is a horizontal line, so the slope is 0. ML, also a horizontal line, so the slope is 0. JM, well, I would rise 1, 2, 3, 4, run 1, rise 4, run 1, and it's a positive sloping line. LK, 1, 2, 3, 4, run 1. My slope is 4/1. So I need to finish off by making a statement in the end. I need to say that, okay, these two being the same shows that JK is indeed parallel to ML. And these being the same shows that JM is indeed parallel to KL. So therefore, what did I show by this? Well, I showed that JKLM is a parallelogram. Okay, again, whenever you're showing that, right, it says show that. That means that there's not going to be an answer blank. The work is going to be the answer. What did I need to see? I needed to see two sets of parallel sides. So I need you to show me two sets of lines with the same slopes. I showed one set of lines that had a slope of 0. I had another set of lines that had a slope of 4. So therefore, I said that JK is indeed parallel to ML, and JM is indeed parallel to KL, which means that it's a parallelogram. All right, now, it says write an equation in slope-intercept form for the line that passes through 4, 10 and is parallel to this line. Okay, well, if it's truly parallel to that line, I need if it's truly parallel, the only piece of information I need out of this line is the slope. Okay, see, if the old slope is 6, if I know if the old slope is 3, and I know that it's the new line is going to be parallel to it, I know that the new slope is also going to be 3. two lines always have to have the same slope if they're going to be parallel to one another. So what did I really just say? Well, I want a line that has a slope of 3 that I want it to pass through 0.4 comma 10. And people, we've done this like a million times by now. Slope, point. Okay, let's solve for b. Y equals mx plus b. 10 is equal to 12 plus b. Subtract the 12 over to the other side. -2 is my b value. So therefore, my equation that's parallel is y is equal to 3x minus 2. That's my answer. Okay. Again, how did we do that? Well, we found this old line, and I used the slope as 3 to say, well, my new slope is going to be 3, too. You may think to yourself, well, what happened to this plus 8? I don't care about that plus 8. The only thing that I care about is to make sure that it's not the same in the end, right? And it wasn't, so I'm good. I don't really care about this plus 8. The only thing I care about out of this old line is the slope. I use that slope and this coordinate that I want it to pass through and do that same process where we solve for b. So I'd like you guys to try this one. Now, the only issue with this one is that this is not in slope-intercept form yet. So you're going to need to solve this for y. You're going to need to get y alone before you start creating your new line to figure out what your slope would be. So go ahead, pause, and then play when ready. All right, so let's solve for y. I'm going to subtract the 30 over to the other side. 5y is equal to 4x minus 30. I divide by 5. So y is equal to 4/5 x minus, I don't really care. I mean, it's 30 over 5, which is 6. You know, not to offend you, 6. But I really don't care about that, what that y-intercept is. All I care about is what the slope is. I care that the slope is 4/5 because that's my new line's slope as well. And then the point I want to run through is this 5 comma 7. So we do the same old solve for b thing. Y is equal to mx plus b. So 7 is equal to 28 over 5 is 4. Subtract the 4 over to the other side. 3 is my b value. So my equation is y is equal to 4/5 x plus 3. And there's my line in the end. All right. I hope everybody's having a good day. I'll see you later.